The physics of ice skating.
As everything in life, physics are an essential part of making ice skating possible. Some of the most important scientific aspects of ice skating are the forces of friction, momentum, and Newton's third law. The first force that is proven to be essential in ice skating is friction. There is friction between the blades of the ice skate and the ice. Since ice has less friction than other surfaces, people can glide easier on ice. Friction is the force that resists movement between two objects. Different surfaces have different amounts of friction. Rough surfaces have more friction than smooth surfaces. Ice skating doesn't work as well on other surfaces because the surfaces have more friction. Concrete is smooth, but it is hard to glide on compared to ice. Grass is a rough surface that is hard to slide across since it has more friction. Lastly, carpet is also rough, texture-wise, making it hard to slide across. The reason ice is so easy to glide across is because the friction between the ice and the blade causes a sort of incision into the ice. This causes small bits of water to appear and a reduced amount of friction present. Another important element of skating is momentum. Momentum is the amount of motion an object has. Different kinds of momentum conservation allows you to do different things. When figure skaters spin, they're using angular momentum conservation to spin faster. Angular momentum means to skate at an angle in order to maintain enough energy to complete multiple spins either on the ice or in the air. Before ice skaters start spinning, they accelerate on the ice at a certain angle, and with that angular momentum, they are able to spin multiple times. When ice skaters spin, they keep their arms and legs close to their body so they can spin faster. This is an example of conservation of energy. This is also why when you jump off the floor, there isn't enough energy to propel you into multiple spins. The combined speed of gliding across the ice and the energy you get from jumping off the ground with the methods of energy conservation are what allow professional skaters to make such impressive jumps in the rink.
The final force involved in ice skating is Newton's third law. Newton's third law states that for every action force applied onto an object, an equal and opposite force is returned. This law is what explains the impact of collision. It is the reason why you feel anything when bumping into things. This is shown in ice skating when ice skaters fall onto the ice or bump into other skaters.
If an ice skater falls on the ice, the action force would be the force applied onto the ice upon impact. The reaction force is when the ice applies the same force back at you. The reason why you may feel a little bounce and rebound is because you have far less mass than the ice you are falling onto.
The forces of friction, momentum, and Newton's third law are essential for ice skating. It allows us to glide swiftly across the ice and feel the result of falling flat onto the rink. They explain why we don't risk skating on concrete and why a triple axel is so hard to do. These forces are essential for not only ice skating to exist, but most things in life. Physics is extremely critical towards our understanding of the Earth and beyond.
Oh my god.